Good morning and good evening for those of you who are not in the Pacific time zone. Welcome to the Network Automation Task Management Vivid seminar today. Next slide. This is brought to you by Chris Powers and myself and the Vivid organization. This is the NA SIG Special Interest Group. Next slide. Our presenter today is Sriram. He's an HP&A developer, and he will be presenting the material. Next slide. Some housekeeping. This is a live session and is being recorded. The recording will be available to all members after the session, so please let other people know that this data is out there. We will have Q&A, and please type all of your questions into the question panel, and I will be moderating those at the end of the session. Next slide. Webinar control panel, just a little bit of toggle view between full screen modes and things like that. So next slide. And take it away, Sriram.
Hi guys, good morning and good evening. So let's go through a few slides that talks about the agenda and what's not on the agenda. So today's agenda is to talk about two main topics. The first one is the NA task lifecycle, from the task creation to task deletion, to what stage it gets into, how it gets executed. And the second part of the discussion is to talk about the task engine. Okay, we have a task and we have task lifecycle. And how do you configure these tasks? How do you configure the task engine? That is the second part of the agenda. And okay, I'm making a couple of assumptions here. So this discussion mainly applies for 9.11 release and beyond. You may see, for some points, you may see HS. That indicates it's a horizontal scalability only. And we are not going to discuss the entire feature set here because of the time limitations. Here it's mainly about some best practices, some introduction to a couple of features so that you have time to explore, and the documentation is available. So you can go through the documentation and get into the next level. Okay, what's not on the agenda? So I'm going to avoid any discussion about the previous versions of 9.11. And this is about the tasks at a very abstract level, at a high level. It's not about individual task details. I won't be getting into how a diagnostic task is going to work. I won't be getting into how a snapshot is going to work. It's not about the specific task internals. Though there are some points that are related to the horizontal scalability, but the horizontal scalability in-depth is planned for the Wednesday talk. And again, we are not going to discuss about the future plans or the enhancements. Probably this is not the best place. Okay. Before getting into the life cycle, I have a couple of important attributes you want to keep a note on that. So the first one is the scheduled date. So it's very important we understand these three timestamps or the three dates. The first one is the scheduled date. So user has configured a task to run, let's say, Wednesday 5 p.m. That is the scheduled date. Or when he created a task, he said run ASAP, as soon as possible. Then now is the scheduled date. It's a date when the user wanted the task to run. And when you create a task, immediately it will be in the pending state. We'll discuss about the states a little later in the discussion. Then the next important timestamp is the start date. Okay, user said to run this task on Wednesday 5 p.m. But it's not necessary that it's going to run on 5 p.m. It depends on many factors. One could be at Wednesday 5 p.m. your NA is shut down for a maintenance or for a patch. So it may not run exactly at 5 p.m. Once the NA comes back, it may start running. So the start time is the time when the task actually runs. So the start time could be same as the schedule time, or it could be even greater than the schedule time. So this is very important to know the difference between the schedule time and the start time. The next one is complete date. This is straightforward. This is the time when the task completes running. And the duration, again, this is very important. The duration is calculated as the difference between the complete time or the complete date and the start date, not the schedule date. So again, these three timestamps are very important to know. We have a schedule time or a schedule date, and we have a start date, and we have a complete date. Now, let's get into the life cycle. So the first important part of a life cycle is the creation, right? How do you create tasks? So we just already talked about that. Tasks could be created to run immediately, ASAP, or it could be in the future by scheduling a task. So there are certain types of tasks you want to know. One is the group task. This is the type of task which runs on devices, a set of devices or device groups. For example, run a task on the inventory. So it's going to run the snapshot task on the complete inventory. The important thing to note is the task is created and its children, the child task, each task belongs to the particular device. Those are not created until the group task starts running. Other thing about the group task is not really doing any really collection of data or talking to the devices. Its main purpose is to start running, create the children, and does some housekeeping. Basically, it keeps a track how many children are failing, how many children are running, and once all the children are done, then it also completes its task. It's a kind of a grouping, logical grouping of the tasks. And the other important point which I mentioned is the children are not created till the group task starts running. That means if you schedule a group task, let's say for Wednesday, today is Monday, right? So Wednesday, 5 o'clock, and you schedule a task for all your Cisco devices. So the child tasks are not created. There will be only one group task, and it will be in pending state till Wednesday 5 p.m. Once Wednesday 5 p.m. comes, let's say you have enough resources and NA is running, then it starts running. The first thing it will do is it creates the children for all the Cisco devices, and the children will continue to run. The other important point is the priority is passed to the child task. So if you create a group task with a priority 4, all the child tasks will have priority 4. The next important task type is the parent task. So I'll take an example. If you do a driver discovery, the driver discovery completes, and after the completion of driver discovery, it spawns a new task, which is a snapshot task. So a task completes its execution. After that, it spawns a new task. So that is called parent task. And again, here the priority is passed, and the parent tasks are not counted in the max group task count. We'll discuss more about the configuration in the second part of the discussion, so I'll revisit that max group task count. The next important type is a child task. We already talked about that. So any task that has a parent task, it could be either group task or it could be a parent task. It's called a child task. So there are few other task types like multi-step project, synchronous task. I'll leave it to you guys to explore in the documentation. But these are the primary 3 important ones. So going further on the creation, when you try to create a task, you can assign a priority. The priority is between 1 to 5, 1 being the highest and 5 being the lowest. And if you want to create a task that is at the priority 1 level, you require an admin privilege. A user requires an admin privilege. By default, the priority is 3. Now coming to the task queuing, how the task gets queued and how before getting executed. So by default, we have a queuing algorithm, which is called priority round robin FIFO. I won't be getting into too many details, but what I'll do is I'll try to explain that algorithm with an example. Let's say you have 3 group tasks. G1, G2, and G3, as I mentioned, as I'm showing on the slide. And G1 is going to run on 5 devices. And G2 is going to run on 3, so does G3. So G1 is going, when it starts running, it creates 5 child tasks. Let's say C11, C12, so on. G2, C21, so on. G3, C31, so on. So we have 3 group tasks that are going to run on Wednesday 5 p.m. and they're going to have equal priority because you created with the priority, let's say 3. Now what happens when Wednesday 5 p.m. comes? Assume that we have resources and NA is running. So these 3 group tasks will move from pending to running, will start running. So the first thing they do is they create the child tasks. So C11, C21, so on. So they create the child tasks. Now the order of these child tasks would be, remember we said priority, round robin, and FIFO. So but the priority is same, so you can ignore it. Now round robin. So what it will do is first it will pick C11 to execute, then it will pick C21 to execute, then C31, then C12, then C22. So you are getting right. It is doing a round robin among the group tasks. Priority, round robin, and FIFO. And the children are created in the order of FIFO in each group task. So it's a very simple example. Now let me make this example a little more complicated. Let's introduce the priority. Now I have 4 group tasks. Note that G1 and G2 are at priority 3. And G3 and G4 are at priority 2. Now I'm sure that you might have guessed it. So when Wednesday 5 p.m. comes, it will pick C31, not C11. The reason it will pick C31 is G3 and G4 has a higher priority. So the first task it will pick is C31 and C41, C32, C42. Once the priority 2 tasks are completed, then it gets into the priority 3. So this is how the task queue is managed. I just gave a very simple example with the group tasks, and the same thing applies with the subtasks also. So we talked about the creation. We talked about how the task gets queued. Now let's get into the very important aspect, how the task gets executed, the execution part of the life cycle. So the first thing when I talk about execution is, we have the question, how many tasks are running? So for this, we have improved the task load page in 911. So if you go to the, let me get into the NA and show you. So let me log into my NA. So you can get into the task load page from the NA console, from task menu to task load. The same link is available from admin also, I'm sure you guys know. So let me increase the size. Okay. So this is how a task load page looks like. The idea here is we want to give a task information at one place. So now what is the question we are trying to answer? How many tasks are running? So the first thing you can notice is this will, let me take a pointer. So you see, this is the number that you configured in the admin settings. What are the max concurrent tasks you want to run? And this is the number it's currently running. And so many tasks are waiting. And the message is very important. So we try to answer a question. Okay, I configured 65 concurrent tasks to run, but only 20 are running. Why? So the message gives an answer. Why less tasks are running than the configured one? Again, I repeat this one. The idea of message here is we keep getting a lot of questions. Okay, I configured my max concurrent task as 65, but only 40 are running. Why is that? So the message gives that information. Why your currently running tasks are less than the configured one, if it is. In this case, 65 and 64 is almost the same, and one is in the transit state, so we say it's running at the max. Efficiency, let's come to the efficiency
later part of the discussion, so I'll skip it. So, yeah. And you notice, this is a HS example. If you see, there are remote cores here. So this is a HS example, but the primary idea is you want to give the local core information. If it is a single core, only this one will be there, the below one, this won't be there. And you want to give a information about the other cores, how many are running and how many are waiting. So this is a kind of a mini task dashboard. And one thing to note is, observe the information here. So if you are talking about the remote core information, right? Here it says task running is 61. In reality, there it might be 59 or 62 also, because some tasks may be in transition or not. Here the question is not to give an accurate information for the remote cores. There may be one or two, because they may be in a transit state or not. If you want an accurate information about that core running task, you should get into that core console. Otherwise, it's just an idea to give a bigger picture. How many tasks are running in the system? Is there a problem with that core? To give a bigger picture. Okay. Now we answer the question, how many tasks are running? Now the second thing is, this especially comes in HS, where the tasks are running, okay? If you see, this answer at a very high level, like core, I have 5 core box here, and I'm on the local core 3. And okay, I say that, okay, core 5 is running 55, blah, blah, blah. But I want to know what are those 54. I want to see which device is running on which core. Then with 9.11, we have the core information in the following reports. One is, if you go, let me switch back to my, if you go to tasks, on the recent tasks, so I have the core information here. So it will tell me which core this particular snapshot has run. So now the core information is part of the reporting of recent tasks and similarly running tasks. Okay. So I'm opening the running task. I don't have any running tasks. Let me just start a task for us so that we can observe it. So I take a snap, I take a diagnostics. No, in fact, I'll change my mind. Let's take a diagnostics. And take a device, boot time. Okay, while it's running, I switch back to the running task. And I see, okay, I have a couple of tasks that are running in core 1. So in fact, majority of them are running on core 1 because I configured to run everything on core 1. Okay, so perfect. So this is how it looks like. So in the running task, you can see the core information where the tasks are running. Now let's go back. Now I got the other tasks which are running on core 2. You see, it is running on the core 2. So you can see where the task is running in a HS system. So we talk about 2 reporting. One is the recent tasks and the running tasks. So let the task keep running. So I'll switch back to the third one. If you do search for tasks, and you go down, so now the core got added to the search criteria. So you can put whichever core you want, and you can do a search. Now let me switch back to the slides. So to answer the question where the tasks are running, you have running task report, you have the recent task report, and you can always do a full-fledged search for tasks. Now, the next part of the task execution is long-running tasks. I know many people are very interested in this part. So even before getting into that, why do we need to analyze the long-running tasks? For a very simple reason, that some of the bad devices are some of the bad. When I say bad, it's just the devices are slow. or the task could be dragging the whole group task. And sometimes they could be even dragging the whole system down. So the idea here is you identify these and isolate them or remove them from the regular group tasks and run when it's not critical. Or probably want to run all these slow devices in the night or when it's not critical. So it's very important for us to analyze the group long-running tasks, and this changes with the user because it depends upon your user environment. It depends upon many factors, like if you have any old devices that are very slow, or they are slow with SSH, but they are fast with Telnet, vice versa. So we have many factors coming into the picture. So it's very important that you understand the long-running tasks and isolate them and work with the respective teams. Either it could be your device team or it could be the HP team if it turns out to be an application issue. Now, how do you figure out this? Okay, fine, we need to analyze the long-running tasks. But how do we identify the long-running tasks? So, even before getting into that, it's important. We talked about the duration, right? But if you remember, duration is not set till the task has completed. So let's say your task has completed. Then you can use the duration. And we introduce the duration as part of the search now. If you go to the search for tasks again, the duration will turn out. Again, it's equal, less than or greater than. So if the task has completed, then you can do a search on duration. If the task is still running, so instead of duration, because the duration is not set till the complete task, till the task is completed. So if the task is still running, we introduce the start date also as part of the search. Now you want to say start date, let's say it started 1 hour ago and it's still running. You can do that. You can do a reporting on the start date and you can figure out the tasks which are running for a long time. If the task has completed, you can use the duration. For example, let me do one thing. Let me put this anytime. I'll just quickly check if I have any tasks that ran more than 10 minutes. For me, 10 minutes itself is like a big deal, let's say.
Can I just break in here real quick, Sriram?
Sure.
I have a question on the question panel about which NA version you're running off of right now.
Oh, okay. So as we told during the agenda, this is NA 9.11. So that is a patch. That's the next patch on 9.10.02. So as we speak, it is getting released. So it should be available in 1 or 2 days, or it's already available. I'm not. I need to check that one out.
Thank you.
Okay. So what did we do? We ran a report that says duration greater than 10 minutes. That's 600 seconds. Okay, let me pick one task. So wow. So I have a couple of tasks, 31 results. I'm sure I need to figure out why this particular task ran more than 10 minutes, because it's simple snapshot. So probably device had some problem, or probably I don't have the latest driver, so I need to figure that out. But here I'm just giving an example of 10 minutes, but you don't want to be so aggressive initially. Probably we are talking about 30 minutes or 1 hour. So, but important thing is you need to deal with the long-running tasks, and you have reporting and searching available to figure out those long-running tasks. And the other one is you can go to the running tasks and sort the results based on start date. For example, you can go to the running tasks and see which task is running for a long time. So I hope I have some running. Yeah. So I just sort based on the start date, and you'll know which is the longest running task currently. So you have a couple of ways to figure out the long-running task. And the other thing I would like to point out is the task timeouts. So with this 9.11 version, we improved the timeout algorithms. So the idea here is it's going to respect the max task length. So again, we'll discuss about the max task length in the configuration part. But by default, it is 1 hour. So if a task crosses 1 hour, it won't be canceled immediately. It may be taking a few seconds, couple of more seconds here and there. And it will make sure that the task is failed. So it will set the status to failed and the failure type to timed out. Okay, this is something it's pretty new in 9.11. Let's go with an example. I'll go back to the tasks and see, I'm sure, search for tasks. So the failure type is there in the previous versions also, but what we did is we introduced a couple of new failure types. We'll discuss about this cancel by user and course stopped. These are the three new ones, and the fourth one which we are discussing is the timed out. So this failure type is set. Now, for example, I want to know all the tasks that are failed. Then I'll do is select the failure type and select the timed out. Then I'll get only the tasks that are failed due to timed out. So in this particular one, we discussed how to deal with the long-running tasks. We need to analyze the long-running tasks. We need to understand why it is running long. Is it like a device, or is it you have some older versions of the driver, or is it there is a problem with application? We need to figure out that. But we do need to analyze the long-running tasks. And then to analyze the long-running tasks, we are providing certain reports, and we improve the algorithm for the task timeout so that it respects the max task length. Going further, running tasks. Okay, this is a very common question I keep getting. Okay, by mistake, I started a group task on the whole inventory and I want to cancel it. So we improved the cancellation of tasks. But before that, we need to understand the cancellation of tasks is not instantaneous. Just because the task might be talking to a device, so it's not like a switching on or off a light. So it's going to take a couple of minutes because we want to do a clean cancellation. And we improve the task cancellation. And the important point to note is, again, the status will be set failed, and the failure type, which we just discussed, will be set to cancel by user. For example, as an NA admin, you want to find out how many tasks users are just launching it and canceling it. You do a report on that. So you go back to the NA and you say failure type is cancel by user when the task is in pending state and cancel by user when the task is running state. And you do a search for that. Let me do a search like how many tasks got canceled. So here is the failure type that got set, cancelled by user when it was in pending. So you'll get the report. So again, this will help in improving your task management. And you want to know whether too much trashing is happening. And again, improve the cancellation algorithm so that if somebody by mistake launches a group task in a huge device group, he can able to cancel it. Or if he wants to run cancel for any other reason, you should be able to do that. So that's about cancellation. Okay, till now we completed the task creation, task queuing, and then we completed the task execution. And now we want to talk about the end states. Again, end state management is also very important. So what are the end states? We have 4 end states: the success, the succeeded ones, the skipped ones, the failed ones, and the warning. Succeeded, I'm not going to touch much on that, but even if a task is succeeded, you want to do, once a while you want to check how long it took. If it is getting succeeded after 50 minutes, you remember our timeout will happen after 60 minutes by default. Let's say a task is succeeded, but it took 50 minutes for running a simple diagnostics, let's say. So you want to figure out why it's running 50 minutes, because 50 minutes seems to be a very long time for a simple diagnostic, let's say. So even if it's succeeded, you want to do some kind of once a while, check it out, is the device slow, or you are having an old version of any, or you are missing a patch. Now, the next end state is the skipped ones. So these are fine. So the reason you want to know is why the reason it will get into the skip state is if a device is deactivated. Then if a device is deactivated and you don't know that, so probably you want to check it out. So you want to do a reporting on the skip tasks and check it out why they're skipped. Generally, two common reasons why a task could be skipped is there is no device driver associated to that, or the device being deactivated. If it was intentional, just remove the skip from your regular group task. Why to waste your resources? And the next one is the warning. This is mainly with the group task. So it depends. It's a child task. If some child tasks have succeeded, some have failed, so it just says it's warning because it's not either failed or succeeded completely. The next one, which is very important, is the failed end state. This needs a lot of attention. We already talked about a couple of failure types, but these are the 4 failure types that are very important in terms of the administration of the tasks. The first 2 is cancelled by user. So you want to know how much crashing is happening, or you just want to rerun. Let's say for some reason I have to cancel my task, but I want to rerun. Okay. Now I'll figure out all the tasks that have failed and cancelled by user and rerun only those rather than the entire group task. And the timed out, we already talked about the timed out scenario. You want to figure out why the tasks are getting timed out and why they are running for so long. Code stopped. Okay. Let's say a task are running. For some reason, you have to bounce the NA because you want to do a patch install, or your system is going down because you want to do a regular maintenance. So this failure tag will be set. So the task will be failed, and the failure tag will be saying core stopped. So once you come back, you can do a search on these task failure types and rerun those rather than rerunning the entire inventory. And that's a very common question we are getting. So I restart, but I don't know which one succeeded, which one failed due to the restart, and I have to rerun my entire inventory snapshot of the diagnostic. So you want to isolate the ones that got affected and rerun those. And there is a small point you want to know. There are some other failure types, but I just want to let you know that those are set only for the driver discovery task. And for other fail types, check the task result that may have more information. Okay, I'm not able to reach this particular device using SSH, or SSH got timed out, or the telnet is not working, blah, blah, blah. So it will have more information on the task result. That is about the end state. The next one in our life cycle would be the archival and the deletion. The archival. So once the task completes the execution, all the data is stored. The task details are stored in the database, and they're available for reporting. And the reporting, you can do advanced reporting, or you can do search for tasks. And you have various criteria. So on the new criteria we introduced is start date, complete date, duration, core, and failure types. That's about archival. Now deletion. So a deletion of task means it is going to erase the complete task details from the database. That means there won't be any trace of that particular task in the NA system as a whole. And the task could be deleted in 2 ways. One is user could do an explicit delete. You can select a task and say delete from the actions. Or the pruner deletes the tasks based on your retention configuration. So you need to check your admin settings, pruner data, pruner configuration, and based on that, the task will be deleted. That means, yeah, I'm assuming that pruner is running and configuring your system. So that is the last part of the life cycle. So the next one is the states of the state transitions. I want to quickly go through this one because it's very important to understand how the task states are changed and what state means what. So let's start with the user. Let's say I have a user. Well, let me get my pointer. Yeah, I have pointer options. Okay, so I have a user here. If you enable the workflow, then once you create a task, it gets into the requested state till it gets approved. Once it's approved, it gets into pending. But for this, the workflow should be enabled. The NA workflow should be enabled. Let's say you don't have a workflow enabled. So once the user creates, it gets into the pending. It gets into the pending. From pending, Either it can go to running or waiting. So you remember, right, we talked about this scenario previously. Let's say my task is supposed to run on Wednesday 5 p.m. So that is in pending state till Wednesday 5 p.m. Now, I have resources available. That means I have enough slots for my task to run. I'm not low on memory and other resources. Then it gets into the running state immediately. But let's say I don't have enough resources and I don't have enough slots available. Then it will get into the waiting stage and it will be waiting till a slot is available for the task to run. Then it gets into the running state. And from running, we talked about 4 end states. The succeeded, failed, skipped, or warning. So that's pretty straightforward. And when a task is in pending, you can pause it and you can resume it. But that's a user action. That is not automatic. And duplicate task. So if you create the same type of a task on the same device, while one task is in either pending or running state, then the second one will be declared as duplicate because the task type and the device are same. I'm sure there may be some questions. Once we have the questions, we are going to come back to the slides. So that's pretty much. And the numbers below are the task status in the database. Sometimes you may need those numbers when you're doing a near CLI. Okay, that's about states and the transitions. Now let's keep moving forward. Okay, the next one is about, this is a very important thing. So you have failed tasks, but how do you rerun the failed tasks? So let's say, these are the such results. Let's say these are all the failed tasks which are cancelled by the user, I want to rerun them. Now, again, the trick here is because the run again is for each task, and I have 5,000 plus results. I can't do a run again for 5,000. That will be almost like I'll be killing myself. So rather than doing that, one small trick is you create a new device, group, temporary, rerun, cancel, and you create a group. So that then you run this particular task on that device group. That would be a very simple way to rerun the failed task. So you have this one. Now what I'll do is I'll do I think I ran a diagnostic, so I'll just run a diagnostic again. Simple. So that is about this slide. Okay, so we're done with the life cycle. Now let's talk about the task engine. Before doing that, I want to quickly check the time. Okay, we're good on time. Okay. Task engine. We talked about the life cycle of the tasks. So there should be somebody who will be orchestrating the whole show. That is nothing but the task engine, and task engine needs some configuration. So if you go to the admin settings server, we have 3 important configurations. One is the max concurrent tasks, the max concurrent group tasks, and the max task length. So the first one is max concurrent task is nothing but number of tasks that can run on a NA core, on a given NA core. It doesn't depend on the group tasks or how many group tasks are running, but these are the real device tasks that can run. So if the number is 50, I could have max 50 tasks. The 50 could be a snapshot, or could be a diagnostics, or could be a combination of both, but not more than that. And this depends on the system, because I can't just keep creating an infinite number of tasks, because I need system resources. The resource could be a RAM, a CPU, a few more. So if we need to, let's say your configuration of max concurrent task is 65, but you have 100 tasks to be run. So 65 will be running, and the remaining 35 would be in the waiting state. So we need to understand the difference between a running state and the waiting state. The next one is the max concurrent group tasks. These are the number of group tasks you want to run concurrently. And most of the cases, the 15 is the default, is enough, because you don't want to run more than 15 group tasks in a normal scenario, unless it's some very specific user scenario. So most of the configurations for the tuning are needed for the max concurrent tasks. And we'll talk about how to tune this one. And the last one is the max task length. So this applies to all types of tasks, any task that runs under any task engine. So this is the max time that is allocated to run. If it is exceeded, the task would be moved to failed, and the failure type is set as timed out. So these are three important configurations for the task engine. Now, tuning. So let me just go back to the admin. So the one which we just talked about comes under admin settings, server. So we just talked about these three settings. Now, let's go back to the task load page. A quick recap. We talked about message, right? Message is going to tell us why the running tasks are less than the configured tasks. We are good at the given instance. For example, here it's saying task is running fewer than a max because there are no waiting tasks, because the waiting is 0. So obviously the running is 0. We don't have anything that is running. Now let's talk about the efficiency. Now, the question we often get is, what is the best value for this max concurrent task? And the answer, as you guessed, it depends. It depends upon your resources. It depends upon your system configuration. You may have less RAM, or you may have more CPUs, and you have more physical RAM allocated. So it depends upon the user environment. So this is what I probably is a good practice. You start with a good number. Let's say start with a default, and use the efficiency as a feedback mechanism to tune this. So this is what we'll do. So we'll go ahead, let's say for example, I configure 20, and I let it run for a day or two and see how the efficiency is looking like. The efficiency could be 3 possible values. One is optimal, moderate, and poor. Optimal means, okay, tasks are running without blocking, are waiting for the resource. So the resource seems to be good, so the tasks are running in an optimal fashion. So that means, okay, there is a chance that I can further increase this. But you remember, you don't keep changing this value very often. Like you want to let the system run for a day or two, or at least for a couple of thousand tasks to run. Optimal means, okay, everything is fine, so probably you want to increase a little and see how it goes for the next. Moderate. This is fine, it's not that bad. Okay, max concurrent tasks, either you can decrease max concurrent tasks or increase the system resources. Probably I need to beef up the RAM, but you can't just keep scaling up the hardware also, because at a certain extent it becomes of no use. And the next one is poor. Oh, this needs very immediate attention because you may be getting into a lot of problems because your resources are not enough, or you configure really high value. So poor needs immediate attention. When efficiency gets into poor, the NES behavior may be, the task behavior may be a little unpredictable. You may be seeing a lot of memory issues. So again, to recap, the idea is you let NA to run a couple of tasks, couple of thousand tasks. It depends upon your environment. I just leave it for a couple of days and see how the efficiency is looking like. If it's an optimal, probably you want to increase a little and see how it goes, and see till what is your max peak your system can reach. So it is if you see here, right, we are not, NA is not really recommending a number. Based on your system resources, NA is giving you a feedback loop so that you can come up with a better number. So we have 3 possible values: optimal, moderate, and poor. Poor needs immediate attention. And when you tune this one, don't do in a drastic, big, huge steps. Do it in a small steps. Increase or decrease. Probably, let's say you have 65 right now. If you want to increase, do it by 5 or 10 and see how it's going to behave. And how this efficiency is calculated? I added this one because I want you to know that we're not storing this efficiency. So when NA gets restarted, the efficiency gets reset because the efficiency is getting calculated in memory. So whenever you change the max concurrent task, again this gets reset. So this is a feedback loop so that you can tune your task engine to run optimally. Okay, that completes my configuration part also. So let's do a quick recap before taking the question. So we talked about the life cycle from creation to deletion. The important thing is how do you manage the end state, especially if the end state is a failed one. Then we talked about how to identify the slow device or tasks because that's very important because it can take the whole system health to a very bad state. It's very similar, right? One bad application running on OS can really degrade the OS health. And we discussed about identifying those and how to mitigate. We have some plans like isolate them, run them separately when it's not critical, and talk to the device team, your device team, or talk to the NA support team and figure out why the task is running slow. And then we discussed about the task engine, how to configure the task engine and how to tune it based on the feedback mechanism. So that's pretty much it on my agenda today. And Wendy, I'm open for the questions.
Great, thank you. So the first question from Spiro, are these new fields in existing pages, task load with /core breakdown, etc., going to be in patch 9.2.01?
Okay, the first question is just task load. 9.2.01, sorry, 9.20.1.
Yeah.
That is already released, so it is not part of that patch. It would be the next patch of 9.20. It would be in the next patch of 9.20, yeah.
Great, thank you. Next is on the are starting 6 or synchronous 8 still valid? What do those states mean?
So we are going back to the states page. Let me go there. Yeah, could you repeat that question for me, Wendy, please?
Yes. Are starting 6 or synchronous 8 still valid? What do those states mean?
Okay. So it's about the synchronous tasks. So to answer this question, let's understand a little on the synchronous tasks. The idea of synchronous task is, the fundamental idea is, I don't want that to be part of task engine. I just want to run now, immediately. Even if I have a slot available or even if I don't have a slot available. It doesn't matter, I want to run immediately. And you can do that using a NA CLI. But the thing is, you want to do that only if it is super critical. You don't want to schedule all the tasks using synchronous just because it doesn't go through the engine, and you won't get this throttling. You won't get any advantage which any task engine gives us. So it should be used with extreme caution only when it's required through NA CLI. So to answer that question, it doesn't get into any of these states. It just runs on the current thread. So it doesn't even come to the NA task engine.
Great, thank you. Next question, are total task max concurrent plus max group?
Total, so
task, yeah.
Okay, yeah. Let me go back to the tasks. So the answer is yes and no, because the max concurrent task means the tasks that are running on the device. So if you see that you are implying that total task means the total tasks that are running on the system, then the answer is no. The total tasks that are running on that particular device is controlled by max concurrent tasks. The max concurrent group tasks are nothing but just the group tasks that are orchestrating its children. So let's say let's take an example. Let's say my mass concurrent group task is 20, and I'm running 10 group tasks. So 10 group tasks will spawn, let's say, 20,000 children. So those 20,000 children, out of them only 50 will be running because 50 is my mass concurrent task. It could be any 50. Does that answer your question? I hope. If not, please rephrase. Wendy is going to take it again.
Okay. And if that, Scott, if that does not answer your question, please post a follow-up, please. Does efficiency consider JBoss tuning settings?
Does the efficiency consider the JBoss tuning settings? So I think the gentleman here is referring to the JBoss memory settings. If you are referring to the JBoss max memory, yes, it will consider that.
Okay.
So when I say max memory, I mean the max heap memory in the jbosswrapper.conf. If you are referring to that, yeah, yes, the answer is yes.
Right. Oops, I should have sent that publicly. Okay, and let's see if we've got any other. Is this a dev nightly build oh, wait, we already talked about that. Next, talked about that. Just going through the questions to see if I have anything else here. Okay, so running 9.11 patch 2, same as you are, task load page looks different. Core is not listed, efficiency not listed. Is there some configuration required to add this?
So I don't know, because it's getting released as we are speaking. So I'm not sure if anybody got bits for this, unless there's an early beta program, which we do with certain customers. So if they belong to the early beta program, I'm sure that they might have got the README with that. If they enable that README, they will see this information. If they're not part of this, then the patch is getting released as we are speaking. Yeah.
Great. Thank you. When a task will go to skip status, when will a task go to skip status?
Okay. So when does it start getting to the skip status? So the two main reasons. One is you try to run a device task and there is no device driver associated with that. Obviously, without a device driver, you can't speak to a device. So task engine figure out, okay, there is no device driver, I can't speak to this, but this is neither success or not failure, so it will move to the skip state. And the other reason is, one is when the device is deactivated. Let's say for some reason somebody deactivated the device. So obviously I don't want to run a task on the deactivated device, so I'll go into the skip state. The next one, please, Wendy.
Yes, I was just typing the answers as we go along. Has the JBoss config file changed in 9.11 so there's no need to tune the different settings in order to increase task numbers?
Yes, yeah, it's not changed.
Okay, or is there still dependency on the JBoss config, and if has low values, then we're limited in the tasks?
So there is, if you see, right, the way we didn't change anything drastically. We just provided a way for you to know the efficiency of the engine so that you can tune it. As we are saying here, right, let's say it's a moderate. So probably you want to decrease the max concurrent task or increase the system resource. And one way to do is you go to the jbosswrapper.conf, and if you have enough physical memory, you bump up little NA heap memory also. So there, just to summarize, paraphrase, there is no change with the configuration of jbosswrapper.conf. We have just provided a way to give more visibility into what's happening with the engine. Is the engine is running optimally or is it running bad? So that you can tune the configurations.
Great. And what about satellites?
This is about the NA application engine. There is no changes for the sidelines here.
Great.
That's part of this. Yeah.
For group tasks, are cores still assigned when the task, when the task is created? When we have hundreds of tasks in a group, the one on the HS core may end before tasks on the other. The wait task on core 2 should be able to load balance the core.
Yeah, this is a very interesting question. I would like to take this question on Wednesday when we complete the horizontal scalability.
Okay.
Yeah, because we're going to discuss more about that.
All right. I have an answer to the question about JBoss wrapper config. It is changed in 9.20.01, and I'm assuming 9.11 also. It is now will set the max and concurrent memory at installed upgrade based on the total memory available to the NA server. The young garbage collector setting is now not configurable. It is automatically set to 1/3 of the max init memory.
Mm-hmm. So, yeah, that's a feature that got into 9.20. And basically, during the installation time, you can set the values. And again, there is no change with that. So if you see here clearly, right, and that is not part of 9.10 or 9.11 also. The feature or the changes we introduced here, we're not really changing anything with that. We're just giving a visibility to the NA engine. So let's say you configure at the install time, and your number of devices for the period of time got increased, right? Or let's say your number of tasks got increased after a couple of months after you install it. So it needs to be tuned again. So the important aspect we need to understand is this tuning is not a one-time job. It depends upon multiple variables, depends upon how many tasks you want to run, how many devices you are managing. And after the installation, these numbers could change. So this is trying to give you visibility into your current NA state, because things may change after you install it. So this is not replacing that one. This needs to be used in conjunction with that one.
All right, and I think that is all the questions we have. Anyone else have any questions? Please post them in the question area. And I'm not seeing any additional, so I think that ends our session for today. Thank you, Sriram, for presenting, and for all of you for attending.
Thanks all. Bye.